Hi everyone, so today we are going to solve the last problem of fixed size sliding window, which is sliding window maximum, and it comes under the category of hard. So let's see the problem, and this is the problem. You can read this problem, and I'm going to explain the problem, what problem says. So we have a num array and an integer k. So we have to find the for every subarray we have to find the maximum of it and return that, and the subarray should have a length k. So in this case k equal to 3. So if you were find the all the subarray whose length 3, so it will be, this is the first subarray you'll get, then the second subarray is this, then third is this, and fourth is this, and sixth and seventh. So this is the subarray you'll get of length 3. So we will go one by one, and what we have to do, this is the subarray, and we have to find maximum of all this element present inside this. So max of 1, 3 and minus 1, and as you can see 3 is the maximum. So we have to put this 3 inside a vector. Let's call it an answer. Okay, now we'll go to next subarray, and next subarray will be this one. And if you find this maximum for this subarray, you'll get 3 minus 1, you'll get 3. So put that 3 into our answer and go for the next subarray, and we have to do the same thing for all. So let's do it quickly. So for this you'll get a 5 as a maximum, and for this you'll get a 5 again. Then go to next subarray. Next subarray would be this one. In this case the maximum is 6, and for the last subarray would be 3, 6, 7. So it would be 7 is the maximum. Now you cannot find the subarray whose length 3, because if you start from this, you only have 2 elements left, but you need 3 elements to form a subarray whose length is 3. So we can't form a subarray. So this is our answer, and we have to return this. Okay, so how we are going to approach this problem? So very first approach is brute force approach. We will try out all the subarrays, and we will take those only subarrays whose length is 3, and find out the maximum and put that maximum into our answer. So there is one more, like, consider this as a first element of a subarray, and if you consider this as a first element, then you need 2 more elements to complete the subarray. So you can take the adjacent elements. So 2 and 3 are taken, so this is the subarray, and just find out the maximum of it and put that maximum into our answer. We do the same thing, like, first of all we will consider the zeroth index as a first element of a subarray. Now consider this, one second. Now consider this as a first element of a subarray. You need 2 more, so you'll go to its adjacent. And if you have a k equal to 3, then this is the first element, we need 3 more, so we will consider this and this, not 3, I'm saying 4, sorry. If you have a k equal to 4, and if you consider this as a first element of subarray, then you need 3 more, so you have to consider this and this and this. So your subarrays look like this. So I am saying that go to every index and consider that index as a first element of a subarray, and then go to every elements of a subarray and find the maximum of it. Okay, so let me do quickly a pseudo code here. So vector, this is going to store our answer. So the first array, first loop, int I equal to 0, I is less than n, I plus plus. Okay, this is the first loop. Now let's say if you are at this index, and if you consider this index as a first element of subarray, now you need two more elements to complete the subarray of size 3, then 1 and 2. As you can see, there is no elements are present. So we have to check if my I plus k, 6 plus 3, if you do 6 plus 3, you'll get 9. If you do 6 plus 3, and the size of array would be 8. So I will check if my I plus k is greater than n, then I will return, sorry, not return, I will break the loop here. So break. We no need to go for the next index and consider as a first element. We will stop here. Now we will consider every index as a starting element. So it will be int j equal to I. This is the starting element, and we have to go up to I plus k and j plus plus, and we will initialize an maxi variable with minus infinity, and you can take as a minus 1e9. It will approximately minus infinity, you can say. Okay, so in this we have to just do this thing, maxi comma array of j. We have to do this. After this loops end, we have to put whatever maxi is. So push back maxi to answer. Okay, so this is the solution. At last we have to return answer. Okay, so this is our brute force approach, and if you try to find out the time complexity, the time complexity it is going to be like outer loop takes big O of n and inner loop takes big O of k. So it will become n into k, and in a worst case, let's say k is equal to n. So the time complexity in a worst case would be n into n, which is nothing but big O of n square, which is huge, and space complexity would be big O of 1, constant space-time complexity. So can we optimize it further? Yes, we can use a sliding window technique over here, and we will able to uh, optimize this solution. So let me erase this quickly, and yeah. Okay, so we have given this array and integer k, and we are doing like first of all we will create a window and then move window by adding and removing elements. These two steps we are doing for the like past few problems. In a past few problems we are doing these two steps, and we are able to solve that problem. In this problem, in this question, we are also doing that. Like first of all we will create this window of size k. In this case the size is k, so we will create initial window by applying some for loop separately. Okay, this is the initial window, and after creating initial window, if we want the next window, if we want the next sub array, then you have to move this by one by adding this element or removing this element from the previous one. If you want the next one, then you have to move one more, so you have to add this and you have to remove this element. So we will do the same for generating all the subarrays, or you can say windows. Okay, so this is the approach we are going to use, but in this case what will be our window? A window is like a map. We are going to use a map integer and integer. Let's call it MP. Okay, the first integer, the key, is representing a value or element of the array, and the second value, the value. Remember, map is stores the value in the form of key value pair. So key and value. So value in this case represents a frequency of value or element. Okay, so this is our map is going to represent. So for the first initial window, uh, this is the initial window we have, and if we create a map, why we are using map, not the unordered map? Because map stores the data or key in a sorted manner according to key values. Like if you put the values, let me put, so 1 is there, so 1 has a frequency 1, 3 has a frequency 1, and -1 has a frequency 1. This is unordered, but in a map the elements are sorted in the according to keys. So this is key, so this is sorted according to key. So you'll get like -1 has a frequency 1, and 1 has a frequency 1, and 3 has a frequency 1. So this is the way uh, the data is stored in a map, not unordered map. Unordered means there is no order. uh, it can, and the data is stored in any ways. So let me erase this. Okay, this is int. Okay, so for the first window, the map look like this. And if you want to access the largest element, how will you get the last element? It will be the maximum element we have. So how would we get this? We will like the, one second, let me erase this. In a map, there is called mp.end. This is an iterator which is pointing to the, this is the last element, and there is some element, there is no element, but it is pointing to this, like very last, not the last, but last, or you can say this is the last element. This is, there is an element, assume there is an element, empty element, and this is pointing to this. mp.end is pointing to this. Now how will get the this element, just do minus minus, then you will reach to the last element. Okay, then if you want to access the key, then you have to do first, because the data is stored in the form of key and value pair, like key and value. And if you want to access the key, then you have to like it has a name p, then p first and p second. Okay, this way we are going to access it. So okay, let's go to the next one. So you'll get a 3 for this initial window. So let me create an answer and put that value into our answer. Now if you go to the next window, next window is this. So let me mark this as a previous window, and the next window is this. By adding this and removing this, removing means decrease the frequency, so it becomes 0, and there is -3 introduced, so put a -3 over has a frequency 1. So if you short this, so you will get -1 has a frequency 1, -3 has a frequency 1, sorry, then -1 has a frequency 1, 1 has a frequency 0. So if there is a frequency 0, then we have to remove this. So remove this, and there is one more element which has a frequency 1. Now if you find, how do you find the largest element, you just do like mp dot and which is pointing to some element after the last element inside this map. Okay, now if you want to access the previous, like the last elements, and then we have to do minus minus. The iterator goes here, the iterator is pointing to here now. One second. Okay, so this is minus minus. Okay, this is pointing to here now, and this is in the this is stored in the form of pair. And if you want to access this, the first element, then you have to do this first. Okay, so you'll get a 3, so you put that 3 into our answer. So this is 3, and we have to do the same thing. If you want to uh, go to next window, then you'll just do this by adding this, and by removing this you'll get the next window. In the frequency map we have to do the same. What will be the time complexity it will take? Like time complexity, it will take big O of uh, n for a sliding, and log k it will take for insertion and deletion of in a map. In unordered map, the insertion and deletion will be big O of 1, which is constant. But in a, uh, in a map data structure, it will take log of n, but in this case k is the size of this map, so the time complexity will be n log k, and the space complexity would be big O of 1 constant space. So we'll do that in a coding so that you will understand better. So let's go and let me create a variable n equal to array dot size. It is going to store the length of the size. So we will create a map of integer mp. So first integer represents key, and the second one is represent the frequency of that key. Okay, now we will create a window. So first step is create a window. So window would be int I equal to 0, I is less than k, I plus plus. Okay, so we have to do array of I. For every element we have to count the frequency, and the window, initial window is created now. Okay, sorry, initial window is created. Now we have to create a vector answer, which is going to store answer. Now the first, for the first window we have to put the answer. So answer dot push back. What we are going to push? So we are going to push a maximum of this window. So how would we get the maximum? So let's create a maxi, and as I told you, mp dot and it's point to the last of very last element. And if you want to get the last element, then you have to do minus minus. And after that, if you want to access the key, so you have to do first. So after getting maximum, we just push back maxi into answer. Now the second step is to move window by adding and removing elements. So we will start from I equal to k, I is less than n, I plus plus, and we have to add element. So array of I is going to increase the frequency. So add, this is add, and we have to remove I minus k and remove the frequency by 1, and this is remove. And whenever, if my array of I minus k becomes 0, then we have to erase this from the map. We have to remove this from the map. So it will be erase array of I minus k. Okay, after doing the doing this, you will get a new window, and let's find a maximum for that window. It will be minus minus mp dot and its first value. So first, and I'm going to put that value into my answer. So answer dot push back maxi. After this loops end, we'll just return an answer. Okay, so this is accepted, and if you submit this, it's totally accepted. So what is the time complexity it will take for the outer loop? It will take big O of n, and for the inner this adding and removing will taking big O of log k, because there are only k elements present, worst case, and big O of log k. So adding and removing will take big O of log k, or accessing is also, I think, the one. Okay, so this is the time complexity. Can we do better? Yes, we can do better. Like, we can remove this log k time complexity by using deque. Since the video is goes very long, so we'll do the deque approach in the next video. So thank you for watching.